Once again, welcome you all of you the lecture series of the microprocessors and the microcontrollers. Okay. Now today we are going to discuss the memory organization of 8051 microcontrollers. Memory organization of 8051 microcontroller. Okay. This memory organization is somewhat different from the microprocessors. Why? That means you see this. Microcontroller basic structure. There is an internal and inbuilt on-chip memory of RAM as well as ROM memory. Okay, but in microprocessor we are connecting an outer side of the memory that may be of RAM and ROM outer side memory. But here microprocessor we are going to connect, or within the chip we have the some amount of memory is available. At the same time, if you want that one, you are also connect the internal and as another external memory. Okay, so now see this. So we know that the main difference between the microprocessor and the microcontroller memory is, okay. So in the microcontroller, so the memory nothing but ROM memory as well as RAM memory. RAM memory you can call it as a data memory. ROM memory you can call it as a program memory. So which are available on the chip only. Or you want that one, you can access in the outer side also. But in microprocessor, as to externally interface with the memory modules. So there is no internal memory is available in the microprocessors. So before going to that microprocessors as well as microcontroller, we are going to discuss about the basic architecture of the microprocessors and as well as the microcontrollers, on which base they can develop the architecture of the microprocessors and microcontrollers. What is the basis for that one? So that that computer architecture can be designed by the uh, two institutes. One Newman, he is the scientist name. One Newman architecture or Princeton architecture. You can also call it as a Princeton architecture. One Newman or Princeton architecture, and second one is the Harvard architecture. Okay, see this. What is the difference between these two? Now see this in one Newman architecture. So this one Newman architecture. See this. Princeton architecture. So it has the CPU. It has the CPU. Okay, it is like some central processing unit, nothing but as well as in this one CPU you have the ALU, then timing and control unit, as well as some registers, and as well as kind of input output devices. At the same time, you have the memory of data RAM or program RAM. This may be a microprocessor or microcontroller. This architecture is common for both microprocessors as well as microcontrollers. Similar architecture. So whenever you are call it as a memory, so that may be of RAM and ROM. RAM and ROM. So you can access this RAM and ROM by using the same address as well as data bus. It's nothing but D0 to the 7 in nothing but the microcontrollers. In microprocessor, we have the D0 to the D7, at the same time D8 to the D15 lines are there. What are the address lines for A8 to the A0 to the A15 address lines are available. Okay, this is so, and single bus is sufficient to access as well as access the memory. But the Harvard architecture is somewhat different. So you can consider the data memory as well as program memory separately. In nothing but so in the sense. So now see this this data memory as well as program memory are separate. Remaining are common. This is common. This is common. This is only the difference. Now see this. These are not available. Nothing but for accessing these two memories, we are using a different buses. So the advantages of this type of architecture is you can access both instructions at the same time, program memory at a time. This way. Okay, so this is the difference between these two. But what is the difference between this one new one as well as R-wood architecture? So what is the advantage of architecture, R-wood architecture? You can access both codes. I mean, a program memory, you have the codes at the same time, memory same time, because you have separate address as well as the data buses for both the data as well as program. But in case of but in one human architecture, this, so you are not accessing instructions as well as data at a time. This may be if you are accessing instructions once, then after the data next. Okay, one by one, because we have only the one address line as well as the one data line. Nothing but there is no additional address as well as data lines. So but here we are using a separate address and data lines for data memory, at the same time separate address lines for program memory in hardware architecture, Harvard architecture. But which architecture we are following? So this architecture we are following. So whatever we are discussed so for 8086 microprocessor or 8051 microcontroller architecture is designed based on the one human architecture. Okay, so what is the main when compared to the one human architecture, Harvard architecture, you are accessing both instructions and data at the same time. This is one of the advantage. But what is the drawback of this one? What is the drawback of this one also? We are using a separate addresses and uh, databases. One separate address and databases means it increases the number of pins. Remember, it increases the number of pins. The pins is increases, the cost is also increases. The power consumption is also increases. So that's why you can minimize the architecture and all. You are using the one human architecture or instant architecture. So whatever it may be. So now see this in 80 microcontroller. So see this. You know that. So this is the computer. You can call it as the computer. Computer. This is the CPU. You know that CPU have the ALUs, timing and control unit, as well as the registers, as well as RAM memory, as well as ROM memory, as well as some IO ports. So by using the some interfacing, by using some interfacing, we are connecting the uh, some internal, some external memory of RAM and ROM, external memory of RAM and ROM, or some input output devices, or some input output devices, IO devices. This is the basic structure. So the entire thing is available on the same chip. So that's why you can call it as computer on a chip. So whenever you are talking about the memory organization of the 8051 microcontroller, we need to discuss the both internal RAM and ROM. Okay, at the same time external memory. At the same time, external connected RAM and ROM memories. Okay, so this now see this internal memory. First of all, internal. We are going to discuss the internal memory first, suppose on-chip memory. So two types of memories are available for on-chip memory. So data memory of one is data memory, then another one is the program memory. Program memory. What is the meaning of the program memory? Program memory means here ROM. Okay, read-only memory. ROM means read-only memory. It has the ROM. It has the ROM. Data memory means RAM. Random access memory. This is the read-only memory, ROM. So program memory, nothing but it can stores the instructions. Read-only means you are not able to change that. But nowadays the technology is available. EPROMs are now we are using EPROMs, electrically programmable read-only memory or erasable programmable read-only memory. EEPROMs is also available. Electrically erasable programmable read-only memories. This type of ROMs are also available. So at the same time, nowadays we are also using the flash memory also, flash memory for this purpose, flash memory. So this is the advanced version we are using. Most of the devices flash memory. Okay, so this flash memory is invented by the Toshiba corporation, Toshiba company. So now see this, whenever you are buying the pen drive of Toshiba, they are mentioned on that one also. So inventor of the flash memory. We'll see this. So two types of memories are available: RAM and ROM. RAM is the data memory, so nothing but it can stores the temporary storing data or intermediate results. Nothing but we can perform the medicine operation, subtraction operation, nothing but a arithmetic operation performed by that microprocessor. It get the some results. That results, the temporary results, that intermediate results, that is stored at the RAM, RAM memory. So whenever you want to execute the program, you know that you are writing the human level language program. But microprocessors or microcontroller, they can understand the machine level language. Machine level language. An human being is not able to write the machine level language code. So for suppose when you write the code like move, so we know that that is the move instruction, but microprocessor doesn't understand. So an assembler is there in between the in between us. Assembler is converting some assembly level language program to the machine level language program in the form of 100. Where these codes are available? These codes are available at the program memory. These instructions, these codes are available at the uh, program memory ROM. Okay, not only that, instruction predefined function. For suppose when you on the microcontroller or microprocessor, whatever it may be, it shows some numbers, then configuration, then company name and all. So that type of permanent memory is also stored at one this row. Okay, so see this, this point is important one. Then see this, some microcontroller, it has the both internal RAM as well as internal ROM. If internal RAM is inadequate, internal memory is inadequate, but it is not adequate means here the meaning of this one. If it is not sufficient to, internal memory is not sufficient to store the some data or whatever it may be. So we can add this some external memory is like this. Add this some suitable external memory. Okay. So now we are discussing internal as well as the external. Okay, now see this. First of all, you know that we have the two types of memories are there. First one is ROM as well as the RAM. So now we are going to discuss the ROM. So you know that 4 KB of ROM is available in the 8051 microcontroller. On chip, you have, remember, on chip you have 4 KB of internal RAM. Remember, whenever you are using the word internal, that is available in the within the chip only. So see this. This is the chip structure. This is the chip. So see this. This is the CPU, ALU, then timing and control unit, then registers and all. At the same time, we are at the same chip we are using the internal program memory. What is the size of that one? 4 KB. 4 KB. We are using 4 KB. And internally. Okay, so this for the codes or instructions to be executed are stored in the program. So program memory. Now see this and elaborately how to access this program memory and all. So in case of 4 KB of internal RAM, see this. What is the address space for that one? 4 KB. How to form the 4 KB? You know that microprocessors and microcontroller, they can work on the language called the hexadecimal part. Hexadecimal. They are in hexadecimal. Hexadecimal. But what is the meaning of hexadecimal? What is the meaning of hexadecimal? Hexadecimal means here the numbers 0 to the 9, then A to the F. A means here in our language 10, B is 11, C is 12, then D is 13, E is 14, F is 15. So 15 numbers are there in the hexadecimal format. Hexa means 15. Hexadecimal format. 15 numbers are available. 0 to the 9, A to the F. Total number is 50. 50 numbers are available. So if it is 4K, so now this is the number 4K. That memory is available in the 4K memory is nothing but the 0000 H to the 0 F F F H. We are converting this into the, this will has the 4K. This is the memory size, ROM memory size. ROM memory size. Okay, this is the ROM memory size. Remember, this is also the ROM memory size here. A 4 KB of ROM memory size. So you can convert this hexadecimal to the decimal format. You will get the 4000 bytes of the 4000 or 4 KB memory. So F is nothing but the 4K, nothing but 4000. You know that hexadecimal to the decimal conversion format. Okay, so then for suppose this 4 KB memory is not sufficient to store the all the some ports and all. So you may be connect the some external memory also, external program memory also. External program memory also, nothing but external ROM also we are going to connect here. So how to connect that one? If you are accessing external memory, two pins we are going to use. EA means external access pin. So EA bar pin as well as a BRG pin. So bar pin. So nothing but these are work as a 0. High is nothing but the EA bar. You know that you must you remember the pin diagram of 8051 microcontroller. Those pin we have the bar on that one. Bar means here negative logic. 0 is on, 1 is off. But 0 is high, 1 is low. So if you put that 0 means here, remember that is 0. High means here, remember high means here 0. But that is actually EA bar pin. EA bar. So you must put this EA bar pin to the 1. Then microcontroller is accessing the external memory of RAM at the same time. RAM. So see this, there is some logic, a small logic behind that one. You must understand carefully. You must understand here carefully. A small logic is there. A very interesting logic is there. You see this. What is the internal program memory? Internal program memory is this. Nothing but 4K. This is the internal program memory. External program memory is also the, see this, external program memory is also the 4K. Is also the 4K. Okay, but see this words carefully, but see these words carefully. If the memory address is accessed at the limit, then the instruction are fetched from the external ROM. Address range from see this, what is the address range? 100 FFH to the FFH. 100H to the 000H. Now see this is the number 1, 2, 3, 4. This is the 64 KB. Sorry, I mistaken that. An external memory is 64 KB. Remember, sorry, it is not the 6 KB, 4 KB. This is 64 KB of external memory we are going to count. 64 KB. This is the 5 Fs. You can count the 5 Fs. It is the 64 KB. But see this 4 Fs. It is 64 KB. 4 Fs. 64K. This is also the number. This is also the 64K. But where it is starts at? It starts at the 1000. 1000H. 1000H. What about this 00002? This number 100H. What about that that memory space? Where you can use this memory space? What about the memory space? You know that this is the memory space. See this. This is the once again we can see this. I will draw the See this board carefully. See this. This is the memory space and external. Please keep it in mind. This is the external memory. This is the external memory. External nothing but 64 KB memory. 64 KB memory means here 000000 H to the, remember what is the number, F F F F H, 4 Fs. This is 64 KB. This is 64 KB. This is 64 KB of the memory, the ROM. But here they can mention that 1000 to FFFH. So nothing but it starts at this case. Let's do this. A two-way accessing is possible. So what about this remaining space in this one? So what about that remaining space? Okay. You see this, what about that remaining space of that? So CPU fetches the internal memory from this one to this one. So how to overcome that loss of that remaining memory? Now see this. This is the program memory. Whenever you are accessing, okay, both internal memory as well as external memory in direct as well as the indirect address. Direct as well as the indirect. So now see this. This is the way we are going to access directly. Okay, directly, nothing but internal memory access mode. We can call it as the internal memory access mode. This is the internal memory access mode in this mode. So this is the 4 KB of that ROM. So remember this point carefully. Whenever you are accessing external memory, also in internal memory access mode, in this mode. So what is that in this mode, 4 KB is utilized of the internal chip. This is the computer. This is the computer chip. This is the chip. So remaining, see this, what is the address locations? See this 1000 to the FFFH. This is the 60 KB only. This is not the 64. This is the 60 KB. 60 KB. When you are accessing both internal memory at the same time, external memory at a time, you are going to accessing or going to combine these memories at a time on that time. So 4 KB of internal memory we are using. Remaining, but what is the actual accessing external memory? 64 KB. But where that address is, what is the 64 KB means, starts at the address location 0 to the 64 KB locations. But when you see this in this internal accessing memory mode, where it can start at the 100H to the FFH. Only 60 KB is used. Remaining 4 KB is used as a internal plus. So totally 64 KB. Because we have the address lines remembered, A0 to the A7, A8 to the 15 also. See this. So nothing but 2 power 16 is equal to the 64 KB. These are the 16 address lines. 2 power 16 is equal to the 64 KB. So you are accessing or you are connecting any of the internal, any of the external device that may be of size of 64 KB only. Okay, out of the 64, you are combining these two, or you are accessing internal memory and external memory at a time, nothing but in internal memory access mode. Okay, so out of that 64 KB, 4 KB memory is from the internal memory, then remaining 60 KB memory, it can be taken from the external. Or otherwise, if you ignore the internal RAM, you can access only the external memory. On that time, what is the memory size of that one external memory? And that time external memory, what is external memory? 0000 h to the f f f h. That means 64 KB. You can ignore the internal memory, you can access the external memory. You can consider the internal memory at the same time external memory, and that time it is of 60 KB, so it is of 4 KB. So in internal memory is also added. Okay, now see this is the structure. So this is a computer, you can access external memory, only external memory. So this 64 KB memory is used, you can use in the 64 KB of the memory. So you understand that. So see this I will draw the once again side by side diagram. See this. So in internal memory, considering internal ROM also, so microprocessor is taken. See this. See this. This is computer. This computer. You can take the nothing but 4 KB ROM. Then remaining it will take the external memory. So external memory 60 KB. 60 KB ROM. You can consider both internal as well as the external. But this address location is from 000 h to the 10 f h. But we are considering this internal as well as external memory. This is the location of this one. This is the f f f f h. This is the one case. What is the another case? What is the another case? We are considering only external memory. Only external memory. You can ignore this. You can ignore this. This is the computer. You can ignore this internal RAM. You can only connect the external RAM. Only connect the external ROM. You can only connect the external ROM 64K. What is the starting size? Address location 000 to the f f h 64K. This is the 64KB size. This is the side by side comparison. You can consider internal as well as external memory, and that time internal 4 KB ROM is considered, so you can add it to the this one. So totally 64 KB. You want that, then only you can utilize. Remember these words also. If you want the external memory, then only you can access this one. Otherwise, it is sufficient to run the programs by using only the internal memory of the internal program. This is the only you can access the external. Okay. So this is the one case here. Okay. So now at the same time, you have a data memory. Nothing but RAM is also available. Random access memory. RAM is also known. This RAM we can also call it as the random access memory. So this we can call it as the data memory also. Data memory. So in microcontroller, especially microcontroller. So this data memory or RAM memory is used to store the temporary data and intermediate results that are generated and used during the normal operation of the microcontrollers. So the microcontroller is of the, what is the memory size? 128 bytes of the internal RAM. 128 bytes of the internal RAM. So in microprocessor 8086 microprocessor, memory size is 1 MB memory size. 1 MB. Out of this 1 MB, RAM is divided to the 512 KB. ROM is 512 KB. Equally divided memory space. In 8051 microcontroller, memory. The ROM is 4 KB, RAM is 128 bytes. But actually, this is 256 bytes. Out of this 256 bytes, 128 bytes is used for the temporary storing stores data and all. Remaining 128 bytes is utilized for the SFRs. FRs. Special function registers are nothing but the you know that you have the 32 types of registers. That addressing purposes we are using this remaining 128 bytes of that. Okay, so that's why actually this is the 128 bytes of the memory. This is the 120. So it is 256 bytes. 256 bytes is divided into the lower 128 bytes higher, 128 bytes lower. Okay, lower you can so see this. So that's why so one is used for the temporary storing data and another is used for the SFRs. So that's why we are not considering this as SFR as a data memory. So we are using only 128 bytes. We are considering only 128 bytes for internal RAM. Okay, now see this is the some RAM memory. Now see this. So direct and indirect addressing. Now you know that uh, microcontroller memory. You have the large number of registers are there. So large number of registers are available. Okay, you know that large number of registers. So you have the 32 types of registers. 32 types of registers. So it's nothing but 32 registers are nothing but 32 registers are nothing but accumulator, B register, DPTR register, then power control registers, nothing but PCON register, TCON registers, then TH of 2 registers, so TL of nothing but T means timer control registers, timer mode registers, then PSW registers. These all are 32 registers. These 32 registers were down to the we are grouping to the 4 register banks. 4 register banks. Each of 8 registers. So 4 into 8, 32 registers. How to access this register banks? How to access this register bank? This register bank can be accessed by the pins RS0 to the RS2. Okay, so nothing but so where these are available? These are available on the PSW program status field. So 4 banks. Okay, so these banks can be accessed by either writing the name or writing the code. Writing the code. Name means we are accessing bank 0 or bank 1 or bank 2 or bank 3. So by writing code means for suppose 80H or 20 or EAH something like that. These are the codes for access. At the same time codes also. 4 codes also considered as something. Okay. Now see this. This is the diagram. Now see this. How to now see this. How to access this. So remember, this is the actually 256 bytes. Remember, this 256 bytes is divided into 128 bytes of data RAM, data plus 128 bytes of remember SFRs. Remember, so we are only consider the 128 bytes of the data RAM. So whenever anyone asks that what is the memory size of the internal memory size of the RAM and ROM, you must say that internal memory size of the RAM is 128 bytes, ROM is 4K. Okay, okay, remember this one. So why not you are considering this 128 bytes? So this 128 bytes of remaining memory is used for the storing the codes of the special function registers. Nothing but 32 registers. That's why this is not the data. This is not the data. So RAM is the data memory. So that's why only 128 bytes is utilized for the storing internal data is nothing but temporary results. Okay, so this 256 bytes is divided into the this 256 bytes is divided into the lower as well as higher. So 128 bytes, 128 bytes. Okay, so this lower 128 bytes is used for the data. Higher 128 bytes is used for the SFR, special function register. Okay, now see this. This is the lower. This is the lower 128 bytes by accessing the indirect and direct address. Indirect as well as the direct address. So 00 to the 07H will indicate the bank 0080. FH is the bank 1, bank 2, bank 3, and so on. This now this one 20 to the 20H to 2FH is as the 16-bit address for registers. Then 30 to the 7H is the general purpose registers. This is the one way indirect and indirect address. You will see. You will see what is that one. So 128 bytes means this is 7F. 128 bytes is nothing but the 7F. 7F is nothing but 128 bytes. So see this. So this is the this is combinedly we are using direct and indirect addressing means combinedly we are using nothing but the data as well as the SFRs. This, but we are separating that one direct as well as indirect addresses separately. So this is the memory. See this. So see, this is 80H to the FF. See this. So we are using only. Sorry, this is not the. Yes. Now see this. We are using 80H to the 180H to the FFH. This is remaining 128 bytes. 128 bytes is nothing but the. You are using special function register. This is 128 bytes. This is another 128 bytes. So we're accessing this one. So for suppose we are accessing bank 3. You just write the programming. Bank 3 has the again 8 registers. This is 8 registers. This is 8 registers. This is 8 registers. How to access this 8 registers within bank 3, bank 2, bank 1, bank 0? Those registers we have the codes. These codes are available. So the codes are stored at the SFR registers. Okay, so that you know that data memory, that 4 banks, nothing but bank 0, bank 1, bank 2, bank 3. Each bank consists of 8 registers that are named at the R0 to the R7 is nothing but the 8. So it can be addressed in 2 ways. What are the 2 ways? By the name or address. So by the name is nothing but the RS0 to the RS1. So RS0 nothing but 00011011. Okay, 00011011. Okay, this is bank 0, bank 1, bank 2, bank 3, bank 3. This is the one of the way it represents namely by name. By name, this is the meaning of that. By using address, is not what you specify the each and every code for that one. Is for suppose code 0. I'm using code 0. 80H you are using that code. Or you are accessing accumulator. I think E0 is the code for the accumulator. Nothing but E0 is code for the accumulator. For suppose you are accessing PSW, program status code. You are writing the code for D0H. For suppose you are accessing the serial control or port 1 90H you are using. This is the codes addresses. This is addresses. Okay, what is how much size is used for bank 4 banks. 4 banks is nothing but 32 registers for 32 registers. To remember one thing, by combining internal and external, I mean nothing but the 128 bytes of the RAM memory. So out of this 128 bytes, see this is only again one clarification, that one case, that one we are accessing indirect, remember, indirect and direct addressing. Direct addressing, nothing but indirect and direct addressing means only the same RAM is used for the both the accessing ports as well as data. This is the 128 bytes, this is the 0. So out of this 128 bytes in direct and indirect addressing mode, 32 bytes are for this register bank, allotted for the register bank. 32 bytes are allotted for the 0 to the 32 bytes are allotted for the register bank. Okay, so remaining whatever the remaining size, we can just subtract the size of that one. It's nothing but we can subtract that one. So 128 minus 32, 96, remaining 96 bytes of memory. Okay, so so direct and indirect, and see this diagram again. I can see this diagram. So see this diagram, direct and indirect. So this is occupies the 32 bytes. So again remaining 16 bytes, see this remaining 16 bytes, so these are the 80 bytes remaining. 16 nothing but the 42 nothing but the 48, remaining 80. This is total 128 bytes, so see this. So remaining 16 are utilized for the bit addressable registers. So remaining 16 numbers, remaining nothing but the 16 is nothing but the 16 bytes space is used for the bit addressable registers. Remaining 80 bytes used for the general purpose registers for direct and indirect addressing. Direct and indirect, or otherwise you are using direct address as well as indirect address separately. And that time you are using both 128 bytes of data RAM and 128 bytes of SFR, lower and as well as the higher. Okay, see this once again. See this. This is the SFRs, special function registers. This is the additional memory, indirect address. We are using the additional 128 bytes of that memory, additional memory. Okay, see this. 16 bytes are used for the nothing. This is the address space are used for the bit addressable memory locations. Addressable memory locations. Okay, then what about the remaining 80 bytes? Remaining 80 bytes. So 32 plus, remember 32 plus 16 plus 80 is equal to the 128 bytes. 32 for banks, register banks. The 16 for bit addressable registers. This 80 for general purpose registers memory. So this lower order 128 bytes, again you know that entire memory is divided into the suppose lower, higher, lower as well as higher. 128 bytes, 128 bytes. So again lower 128 bytes of the RAM can be addressed directly or indirectly. So what is the upper 128 bytes of the memory? Upper 128, nothing but lower. What is the address of that one? 0 to the I mean what is this size? This one 0 to the 80H. This one 80 to the then FF, then upper. Okay. See this point, important point. SFR memory can address only the direct address pool. It is not possible to indirect addressing. Okay, so these are the some SFRs. These are the some SFR special function registers. Different type. I think we are already discussed each and every registers. So for suppose so whatever that the data whatever you are adding, that is not sufficient to perform the microcontroller or microprocessor operations. We are discussing microcontroller. For suppose the data 4 KB of ROM, so 128 bytes of RAM is not sufficient to perform the all the operations. And that time you are going to add the external memory. Okay, external memory. Okay, so but we are accessing the external memory. Okay, so see this how to interface that external memory and nothing but RAM and ROM to this 805 microcontroller. You know that 64 KB of RAM we are going to interface the 8051 microcontroller. At the same time 64 KB of the ROM is also connected. RAM is 64 KB, at the same time ROM is also 64 KB. So nothing but 2 power 16, that's lines, nothing but 64 KB. This is the basic structure for interfacing the external memory to the 805 microcontroller. Okay, this is series 64 KB of RAM. You are going to interface that 805 microcontroller. At the same time 64 KB of ROM is also going to interface this microcontroller. By interfacing this two, you are using PSEN pin. Remember PSEN pin, at the same time EA bar pin. Okay, so now see this it is on last point for yes, this second. This is the last point for remembering this one. Interfacing external memory with 801 control is port 0 cannot be used as an input output port. So at the same time, it will be used for multiplexer address and data bus A0 to the A7, D0 to the D7. Do not always do not, but port 2 may be used as higher byte of the address lines. You know that 4 ports are available: port 0, port 1, port 2, port 3. Port 0 is also utilized for AD0 to the AD7. Port 1 is not at all used for any of the multiplex lines. Port 2 is used for the A18 to the A15 lines. Then port 3 is used for the some RDX lines, some RXD lines, some TXD lines, some EA lines, write lines, then read lines, and next 8 lines. So for interfacing this internal as well as external memory to that one, you are using the port 0 as well as the port, because this has the both addresses A0 to the 7, A8 to the 15 lines are available. So by using the address latch enabled, AELA pin can connect the address lines to the data. Okay, so that is the memory organization of the 805 microcontroller. So thank you for joining the today's lesson.